Welcome to this explainer on quantum entanglement. You've probably seen the crazy popular science headlines before: entangled particles somehow whispering to each other across the entire galaxy, moving way faster than the speed of light. Well, they actually don't. Nothing travels between them at all, and you literally cannot send a single message this way. And yet somehow their answers match perfectly, across the galaxy, every single time. So today we're going to break down exactly how particles manage to perfectly match across the galaxy without ever sending a single message. And we're going to keep everything strictly to clear, simple, straightforward concepts. No crazy jargon, I promise. To really appreciate just how mind-bending this is, you have to think about why this concept kept one of the absolute smartest people who ever lived up at night. Albert Einstein absolutely hated this idea. He famously called it spooky action at a distance. He literally spent years of his life trying to prove that it couldn't possibly be real, but, well, he failed. The universe really does behave this way, and the reason it bothered him so much is the exact same reason it should totally fascinate you. It completely shatters the most basic assumption we have about how objects work in our universe, namely the idea that a thing actually is something even when nobody's looking at it. Okay, let's dive into this by peeling back the layers of a completely normal, everyday scenario. Just picture a fancy pair of gloves, one left, one right. A factory seals each glove in an identical cardboard box without looking, and ships one box to a friend in Tokyo and the other to a friend in Lima, right on the opposite side of the planet. Now your Tokyo friend rips open her box and finds the left glove. In that exact instant, she knows, with absolute certainty, that Lima has the right glove. No message needed. Is that spooky? Not even a little bit, right? The factory simply put a left glove in one box and a right glove in the other. The answer was decided at the factory, safely sealed inside the cardboard the entire time. Tokyo just learned something that was already true. We use this kind of logic all day long. But in the reality of the quantum world, things stop behaving like simple cardboard boxes. Now the part that absolutely breaks your brain is this. With genuinely entangled particles, there is actually no glove in the box until someone opens it. It's not that the answer is just hidden from us. The answer simply doesn't exist yet. Before anyone looks, neither particle is left or right. The particle exists in a genuine fog of both possibilities at once. Reality just hasn't made up its mind yet. And boom, here is where the magic happens. The moment Tokyo opens her box, that cloudy fog instantly collapses into left. And in that exact same heartbeat, the box in Lima, which also had absolutely no answer a microsecond ago, instantly locks into right. It is exactly like two undecided coins on opposite sides of the world, magically landing as a perfectly matched pair the very instant either one is flipped. And that is what Einstein couldn't stomach. It wasn't the matching that bothered him, because matching is easy. It's that the matching is arranged after the boxes are sealed, with no physical note inside either one telling it what to be. So a natural question pops up, right? If Lima's particle finds out the instant Tokyo looks, couldn't you build the ultimate faster-than-light telephone with this? Imagine I hand you and a friend each a stack of magically matched cards. I promise you that when you compare them later, every single pair is going to match perfectly. Great. But if you think you can build a faster-than-light phone with this, well, imagine flipping those cards all alone in Tokyo. Looking only at your own pile, what do you actually see? Heads, tails, tails, heads. It is pure random noise. And Lima sees pure random noise too. Looking only at your own data, you can't even tell if the other person has started flipping their cards yet. The crucial takeaway here is the sequence of events. You flip your cards alone. You see only noise. The magic, the perfect matching, only appears after the fact. It only happens when you both physically meet up or send an ordinary slower-than-light email or a phone call to compare your piles line by line. Without that slow, classical communication step, the quantum magic remains entirely invisible to you. Just sit with how strange this is for a second. Because you cannot choose your particle's result to flash an intentional signal. Like, Tokyo can't force her particle to be left just to send a Morse code dot. This connection is incredibly tight, yet perfectly mathematically incapable of carrying a message. It gives you a bond tighter than absolutely anything in the everyday world, but there is no paradox here. There's no broken physics. It's just a correlation that is way deeper than classical, everyday objects are allowed to have. So, how does this actually build into something highly practical? Why should anyone, besides a philosopher, care about this? Well, imagine a simple machine made out of gears. Ordinary gears can each spin on their own, but to make them really work together, you have to bolt them onto a shared axle. You wire them up. Quantum entanglement is literally the hidden physical wiring of our universe. It acts exactly like that shared axle, forcing ordinary separate pieces to think and spin together as one fully connected system. And this brilliantly illustrates the secret ingredient behind three technologies that sound straight out of science fiction, but are actually very real. First up, quantum teleportation. This is moving the exact state of one particle onto another one far away, and it runs on a shared entangled pair plus an ordinary message. Second, unbreakable encryption. This is creating spy-proof codes where any eavesdropper is automatically caught because the mere act of spying snaps that delicate entangled link and leaves undeniable fingerprints. And third, quantum computers. Their raw muscle doesn't come from individual bits, but from entangling many of them so they can explore enormous possibilities as one woven whole. But wait, there is one last twist to this story. For decades, highly intelligent people desperately wanted a simpler explanation. They wanted to know if there was just a hidden instruction, like a secret note, sealed inside the box beforehand, making the particles only look like they were magically connected. Maybe we just weren't smart enough to read the note yet. But physicists didn't just sit around debating this in armchairs. They went out and tested it. Experiments tracking the particles' patterns across many different directions proved something totally astonishing. The results are simply far too coordinated to be explained by any hidden note. They cross this mathematical line that any classical secret note inside the box explanation simply cannot reach. We have run this experiment over and over in labs all around the world, and the conclusion is absolutely definitive. The boxes win. There is no secret note. The universe really is making it up on the spot, together, in real time. So let's quickly review what we've unpacked today. First, the universe decides the state of the particles instantly, but only in the very moment you look. There is no answer sealed inside beforehand. Second, despite this instant link, the connection absolutely cannot carry a message because each side only sees random noise until they compare notes the slow way. And finally, this remarkably strange link isn't just some weird party trick. It's the true wiring behind quantum computing, teleportation, and unbreakable codes. So where do we go from here? Well, next time, we're going to slow all the way down and zoom in on just one quantum bit. We'll look at the Bloch Sphere. It is a beautiful, simple visual tool, literally just a single arrow pointing somewhere on the surface of a ball that lets you actually see a quantum state, instead of just talking around it. Once you can hold that picture in your head, I promise you, almost everything else in quantum mechanics just clicks right into place. But hey, before we wrap up this explainer, I am genuinely curious about your perspective. Even after learning about the gloves and knowing for a scientific fact that there is no secret note in the box, does Einstein's spooky action still feel impossible to you? Or did something in your understanding just shift? Think about it, drop your thoughts in the comments, and keep questioning the universe.